Dear students, welcome. Yesterday, we discussed about the resultant of two forces acting at a point. Also, the components of a force in two directions. If the component of a force are acting in mutually perpendicular directions, then it is called the resolved parts. Resolved part, the component of a force along two mutually perpendicular directions are called resolved parts of the force, and like that. We also discussed about the resultant of a number of coplanar forces. Today, I will solve some problems. Already 4 questions have been written here. Very simple problems. Very simple problems. First, I shall solve these 4 problems. In solving these problems, we will use this formula. The magnitude, I told you that if two forces P and Q are acting at a point and the angle between the two forces P and Q is alpha, then if R is the magnitude of the resultant of the two forces P and Q, then R equal to root of R, P square plus Q square plus twice PQ cos alpha. Also, if the resultant makes an angle theta with the direction of P, then tan theta is equal to Q sin alpha divided by P plus Q cos alpha. Very simple problems. Now, first of all, I am going to solve the problem number 1. What is it? The resultant of two forces P and Q is of magnitude R. If P be doubled, Q remaining the same, so that the new resultant R dash is of magnitude this. We are given that the resultant of two forces P and Q is R in magnitude, of magnitude R. You see, what is R? R equal to root of R, P square plus Q square plus twice PQ cos alpha. We should know the angle between the two forces. Between the two forces P and Q. Let alpha be the angle. Let alpha be the angle between the two forces P and Q. P and Q. Also, magnitude of P is P vector is P and magnitude of Q is vector is Q. Therefore, since R is the magnitude of the resultant of P and Q, therefore R square should be equal to P square plus Q square plus twice PQ cos alpha, since alpha is the angle between the two forces. According to the second question, P is doubled, Q remaining the same, the new resultant is R. Also, according to the question, magnitude, the new resultant, Q remaining the same, new resultant. What is the new resultant? The new resultant is given to be R dash. New resultant square equal to the force P is doubled. Therefore, you will have to write twice P plus Q square plus 2 times of twice P into Q cos alpha. This means R dash square equal to 4P square plus Q square plus 4PQ cos alpha. Now, you see, in the result, there is no alpha. You will have to eliminate alpha. We will have to eliminate alpha from this and this. from 1 and 2. This means you will have to write r dash square equal to 4p square plus q square. 2 times of twice pq cos alpha you may write like this. Or r dash square equal to 4p square plus q square plus 2 times of. What is twice pq from 1? R square minus p square minus q square. It will be r square minus p square minus q square by 1. By 1. Or you may write here using 1. Using 1. Twice pq cos alpha will be equal to r square minus p square minus q square. Using 1. It is obvious, quite obvious. This means r dash square is equal to 4p square plus q square plus twice r square minus twice p square minus twice q square. Or I am writing here, or r dash square equal to twice p square plus twice r square. This twice p square, twice r square plus q square minus twice q square means minus q square. This means r dash is equal to root over twice p square plus twice r square minus q square. This is the answer. We have solved this problem. Number 1. It is very easy. We have given 2 conditions. From these 2 conditions, alpha has been eliminated. Alpha has been eliminated. The result has come. Perhaps you have understood this. Very easy. Number 1. Now I am number 1 has been proved. Number 2. See the question number 2. The resultant of 2 intersecting forces P and Q are of magnitude R. NR and N plus 2R according as their angle of inclinations are 90 degree theta and 90 degree minus theta respectively. Prove that tan theta equal to this. Question number 3. Now I am going to solve the question number 2. Solution of question number 2. You see, when the angle between P and Q is 90 degree, then the resultant is R. We have, by the question, R square equal to P square plus Q square plus twice PQ cos of 90 degree. Cos of 90 degree, according to the question. This means R square equal to P square plus Q square. Since cos 90 degree equal to 0. Since cos 90 degree equal to 0, therefore you will enumerate it. Now, according to the second question, the resultant is NR when the angle between them is theta. Also, NR, resultant is NR, therefore you will have to write NR whole square. P square plus Q square plus twice PQ cos theta. Or N square R square equal to P square plus Q square, you may write R square plus twice PQ cos theta. Or M square R square minus R square equal to twice PQ cos theta. Or you may write N square minus 1 into R square is equal to twice PQ cos theta. Suppose this is number 2. And here using 1. You may write here using 1. P square plus Q square equal to R square. Also, N plus 2R. P square plus Q square plus twice PQ cos, the angle between them is 90 degree minus theta. This means N plus 2 whole square R square. This is equal to P square plus Q square is equal to again R square plus twice PQ. It is sin theta. It is sin theta. Now, n plus 2 whole square minus 1 into r square equal to twice pq sin theta. It is number 3. It is number 3. Dividing 3 by 2, you will get. You will have to eliminate r, p and theta. If you divide 1 and 2, you will get then p, q, r will be eliminated. Dividing 3 by 2, we get twice pq sin theta divided by twice pq cos theta equal to, it will be n plus 2 square minus 1 r square divided by n square minus 1 r square. Twice pq cancel. It will be tan theta equal to n plus 2 square minus 1 divided by n square minus 1. Right? This is equal to n square plus 4n plus 4 minus 1. N square plus 4n plus 4 minus 1. Just factorize this. N plus 1 into n minus 1. If you factorize this, you will get n plus 3 into n plus 1. N plus 1 will be cancelled. This is equal to n plus 3 divided by n minus 1. 2 has also been proved. We have solved number 1 and number 2. Number 1 and number 2. Very, very interesting and very, very simple question. Very easy. Number 3, you see, the resultant of two forces P and Q is of magnitude √3Q, and it makes an angle 30 degrees with the direction of P. The resultant makes an angle 30 degrees with the direction of P, so that either P equal to Q or P equal to twice Q. You see here. Let me write in that. Suppose OABC is a parallelogram, and this force is P, and OC, Q force is this, and the resultant will be represented by the diagonal √3Q. Also, the resultant makes an angle theta. Since OC is equal to this, this angle will be also. Right? See the diagram here. The angle between P and the resultant of P and Q is √3Q is equal to this. Makes an angle 30 degrees with this. You see. Let me solve this problem. What is this? Let OA vector equal to P vector. Means, what we have written here, OA vector is equal to P vector. This means the force P is represented by the side OA of the parallelogram OABC. OC vector equal to, Q vector. And OB vector equal to √3Q vector, this one. Therefore, OA, the magnitude of this is this. Magnitude of OA is, this means I am writing here magnitude of OA equal to OA, like this. And magnitude of P vector is equal to P, like this. I am writing in this way. Now this is angle theta. You see, also AB AB vector is parallel to OC. Now you see OABC in parallelogram OABC, parallelogram OABC, OC is parallel to AB and OC is equal to AB. Therefore, AB vector, this is equal to OC, this is equal to Q vector. That's why I wrote AB vector equal to Q vector. This is not theta, this is 30 degree. It is given to be 30 degree. Theta is equal to 30 degree. It is given. Theta is equal to 30 degree given. Now let me remind you one formula. ABC is a triangle. ABC is a triangle. The sides opposite to the angle A is small a, it is small b, it is small c. What is cos A? B square plus C square minus A square divided by twice BC. What is cos B? C square plus A square minus B square divided by twice CA. Like that. Means, what is cos this? D square plus D square minus D square divided by twice this into this. Here in triangle OAB we get, in triangle OAB we get cos 30 degree equal to, I am using this formula. I am using this formula. Cos 30 degree equal to, you may write here OA square plus OB square minus AB square divided by 2 times of OA into OB. Since cos A is equal to B square plus C square minus A square divided by twice BC. Such formula will be used. This formula has been used here. This means cos 30 degree means root 3 by 2 equal to OA square equal to P square Q square, not Q square, root 3Q whole square minus Q square divided by 2 times of P into root 3Q. Can I write like this? This is equal to, these two will be cancelled. Root 3 into 3, 3PQ equal to P square plus thrice Q square minus Q square. This means P square minus thrice PQ plus twice Q square equal to 0. This means P square minus twice PQ minus PQ plus twice Q square equal to 0. P minus twice Q minus Q P minus twice Q equal to 0. Or P minus twice Q into P minus Q. This is equal to 0. Therefore, either P equal to twice Q or P equal to Q. Either P equal to twice Q or P equal to Q. Very simple problem. This problem has also been solved. Now, I am going to solve the question number 4. Perhaps you have understood this one. Just the trigonometrical formula has been used here. Cos A equal to cos A, angle A equal to B square plus C square minus A square divided by twice BC. Or cos C equal to A square plus B square minus C square divided by twice AB. This formula has been used. Very easy problem. Now I am going to solve the question number 4. What is it? If the magnitude of the resultant of two equal forces inclined at an angle twice theta be twice that when they act at an angle twice phi. Prove that cos theta equal to twice cos phi. Cos theta equal to twice cos phi. Very simple. Two equal forces, magnitude of the resultant of two equal forces. Let the forces be P and P. Forces be P and P. And their magnitudes are, P and P. Magnitude are P and P. Equal forces. Therefore, magnitude of the resultant of two equal forces. What is the magnitude of these two? And the angle between this, according to the equation, angle between them is, if angle between them is twice theta, then according to the equation, what is the resultant of this? P square plus twice P into P. P into P cos twice theta. This is equal to twice that. Twice that means twice the resultant when the angle between them is twice phi. Then P square plus twice P into P cos twice phi. Cos twice phi. Or squaring, if you square it, you will get this one. Twice P square cos twice theta equal to 4 times of P square plus twice P square cos twice phi. Cos twice phi. This one is this. This means twice P square plus twice P square cos twice theta is equal to 4 times of 2 times of P square 2 times of P square cos twice phi. Or twice P square, if you take twice P square common, then you will get 4 into twice P square 1 plus cos 2 phi. 1 plus cos 2 phi. Right? 1 plus cos 2 phi. Simple problem. Simple problem. Twice P square will be cancelled. 1 plus cos twice theta can be written as twice cos square theta. 4 twice cos square phi. Or cos square theta equal to 4 cos square phi. This means cos theta is equal to twice cos phi. Cos theta equal to twice cos phi. Cos theta, this is equal to twice cos phi. This problem has also been solved. It is very simple and very simple question. Let me write 4 more problems. Then we shall solve these problems. First, let me remove this one. You see, I have written another 4 questions. Today's question number 5 is, you see, today's question number 5 is, two forces of magnitude thrice P twice P have a resultant of magnitude R. If the first force is doubled in magnitude, then R is also doubled. Find the angle between them. Find the angle between them. Question number 5. Let the angle between them is alpha. Let the angle between the forces thrice P and twice P is alpha. Here thrice P and twice P means the magnitude of the forces is thrice P and twice P. Therefore, according to the question, you will get thrice P whole square plus twice P whole square. 2 times of thrice P, twice P, cos alpha. You will get this one. Or R square equal to 9P square, 4P square, 12P square, cos alpha. Or R square equal to 13P square plus 12P square cos alpha. Means R square equal to P square 13 plus 12 cos alpha. This one. From the first condition, you will get this. If alpha is the angle between the two forces. Also, if the first force is doubled, then R is also doubled again. Also, according to the question, R is also doubled, resultant is doubled. If thrice P is doubled, thrice P doubled means it will become 6P square. And others will remain unchanged. 3. It will be thrice 6P into twice P, P cube into cos alpha. This means 4R square equal to 36P square plus 4P square, 24P square cos alpha. You will get this. Or 4R square equal to 40P square plus 24P square cos alpha, or divide by 4, you will get 10P square, 6P square cos alpha, or you will get I am writing here. R square equal to P square into 10 plus 6 cos alpha. It will be, suppose this is number 2. Divide 1 by 2. Dividing 1 by 2 we get. Dividing 1 by 2 we get. Dividing 1 by 2 we get. It will be R square divided by R square equal to P square 13 plus 12 cos alpha divided by P square 10 plus 6 cos alpha. This means R square cancel, P square cancel, you will get this one. Cos alpha. You will get this one. Or 13 plus 12 cos alpha equal to 10 plus 6 cos alpha. This means 6 cos alpha equal to minus 3. This means cos alpha equal to minus half. Cos alpha equal to minus half. This is equal to minus cos 60 degree. This is equal to cos 180 degree minus 60 degree. This is equal to cos 120 degree. This means alpha is equal to 120 degree. The angle between the two forces, thrice P and twice P, is 120 degree. 120 degrees. This means question number 5 has also been solved. Find the angle between them is, what is the answer? Answer is 120 degrees. The angle between the two forces is 120 degrees. This problem has been solved. Just let me remove this one. I have solved this problem. Now, question number 6. Let us try to solve the question number 6. Two forces P and Q acting at a point have resultant of magnitude. This magnitude of the resultants are given when they act at an angle alpha and 90 degree minus alpha. When the angle between the two forces P and Q is alpha, then the resultant is twice K plus 1 root over P square plus Q square. And when the angle between the two forces P and Q is 90 degree minus alpha, then the resultant is equal to twice K minus 1 root over P square plus Q square. P square plus Q square, you see. According to the question, we have twice K minus 1 or twice K plus 1 root over P square plus Q square. This is the resultant of the two forces P and Q. Magnitude of the resultant of the two forces P and Q. P square plus Q square plus twice PQ cos alpha. Twice PQ cos alpha. If the angle between the two forces P and Q is alpha, the resultant is this. In place of R, we have written twice K plus 1 this one. This means twice K plus 1 whole square into P square plus Q square. This is equal to P square plus Q square plus twice PQ cos alpha, or twice K plus 1 whole square minus 1 into P square plus Q square. This is equal to twice PQ cos alpha. This will be equal to twice PQ cos alpha. This means 4K square plus 4K plus 1 minus 1 P square plus Q square equal to twice PQ cos alpha. This means this one will be cancelled. 4K square plus 4K P square plus Q square. This is equal to twice PQ cos alpha. Or you may write, this means 4K is common. 4K plus 1 P square plus Q square will be equal to twice PQ cos alpha. Suppose this is number 1. This is number 1. Again, according to the question. From the question, the resultant is twice K minus 1 into root over P square plus Q square. Resultant is this. Twice K minus 1 root over P square plus Q square. Resultant is this. P square plus Q square plus twice PQ cos. The angle between them is 90 degree minus alpha. In this case, the angle between the two forces is 90 degree minus alpha. Let me write it. 90 degree minus alpha. Or you may write, or this means twice K minus 1 whole square P square plus Q square. This is equal to P square plus Q square plus twice PQ cos 90 degree minus alpha means sin alpha. Cos 90 degree minus alpha means sin alpha. This means twice K minus 1 whole square minus 1 into P square plus Q square. This is equal to twice PQ cos sin alpha. Twice PQ sin alpha. This means 4K square minus 4K plus 1 minus 1 P square plus Q square is equal to twice PQ sin alpha, or 4K square minus 4K into P square plus Q square. This is equal to twice PQ sin alpha, or 4K into K minus 1 P square plus Q square equal to twice PQ sin alpha. Suppose this is number 2. This is number 2. Dividing 2 by 1 we get. Two by 1 we get. Dividing 2 by 1 we get. Twice PQ sin alpha divided by twice PQ cos alpha. This is equal to 4K into K minus 1 P square plus Q square 4K into K plus 1 P square plus Q square. P square plus Q square. This means this twice PQ cancel, 4K cancel, K, oh not K minus 1. P square plus Q square, P square plus Q square, P square plus Q square cancel. This means tan alpha equal to, you will get K minus 1 divided by K plus 1. K minus 1 divided by K plus 1. We have solved the question number 6. The question number 6, very easy you see. Tan alpha equal to K minus 1 divided by K plus 1. We have solved this problem also. Let me remove it. Now, question number 7. The question number 7 is the greatest and the least resultant of two forces are F and G in magnitude. The magnitude of the greatest resultant is F and the least resultant is G. Prove that their resultant is equal to this in terms of the greatest force and the least force. Greatest resultant and the least resultant. In terms of the greatest resultant and the least resultant, the resultant is equal to this. When they act at an angle twice alpha, they act at an angle twice alpha. Yesterday I told you that what is the greatest resultant of a force? In the corollary I told you that the result, if the magnitude of the two forces P and Q is P and Q, and the resultant of the resultant of P and Q is equal to R in magnitude, then R square is equal to twice R square is equal to P square plus Q square plus twice PQ cos alpha. Twice PQ cos alpha. R will be maximum. If cos alpha is maximum, what is the greatest value of cos alpha? Is equal to 1. Then R square equal to P square plus Q square plus twice PQ into 1. Means P plus Q whole square. Root over P plus Q, R square is equal to P plus Q whole square. R is equal to P plus Q. Also, the least value of cos alpha is equal to minus 1. What is the least resultant? Then the least resultant R will be equal to root over. R will be equal to P square. R square is equal to P square plus Q square plus twice PQ into minus 1. The least value of cos alpha is minus 1. Then R square is equal to P square plus Q square minus twice PQ. This means R square is equal to P square plus Q square minus twice PQ means P minus Q whole square. R square is equal to P minus Q whole square. Therefore, R is equal to P minus Q. The greatest resultant is P plus Q and the least resultant is P minus Q. If the magnitude of the forces, if the greatest resultant is P plus Q and the least resultant is P minus Q. That's all. That is. If the two forces are P and Q, the greatest and the least resultant of two forces. Let the two forces be P and Q. 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 Therefore, the greatest resultant of P and Q, the greatest resultant of P and Q is P plus Q, and the least resultant of P and Q is P minus Q. Least resultant of P and Q is P minus Q. Greatest resultant is P plus Q and the least resultant is P minus Q. Therefore, F equal to P plus Q, G equal to P minus Q, because the greatest resultant is given to be equal to capital F, and the least resultant is given to be equal to G. Therefore, G equal to P plus Q, F is equal to P plus Q, G equal to P minus Q. If the two forces are P and Q. Now, F plus G, therefore F plus G, this is equal to P plus Q plus P minus Q. This means F plus G equal to twice P. P equal to F plus G divided by 2. F minus G equal to P plus Q minus P minus Q. This means F minus G is equal to twice Q. This means Q equal to F minus G divided by 2. F minus G divided by Q C. The magnitude of we have to find the magnitude of the resultant of P and Q. When they act at an angle twice alpha, let the two forces P and Q. I am writing here magnitude. P and Q is if the factor sign is not given, then you should mean that it is magnitude of the forces. If the two forces P and Q act at an angle, act at an angle twice alpha, then if the two forces P and Q act at an angle alpha, then the resultant R of the magnitude of the resultant of R. Then the magnitude of the resultant resultant R of the two forces P and Q will be P and Q is given by magnitude of the resultant P and Q is given. Magnitude of the resultant is R of the two forces P and Q. R square equal to P square plus Q square plus twice PQ cos the angle is twice alpha. The angle between the two forces is twice alpha. Right? This is equal to what is P? P means F plus G divided by 2 whole square. Q means F minus G divided by 2 whole square. 2 times of F plus G by 2 into F minus G by 2 into cos twice alpha. Cos twice alpha. I am not sure whether the camera is covering this portion also. Let's see. 1 by 2. You may write 1 by 4. 1 by 2 whole square. 1 by 2 whole square. 1 by 4. F plus Z whole square plus F minus Z whole square. Plus 2 to cancel. 1 by 2. F plus Z into F minus Z means F square minus Z square cos twice alpha. This is equal to 1 by 4, 2 times of F square plus Z square, plus half of F square minus Z square cos 2 alpha. This is equal to 1 by 2 F square plus Z square. 1 by 2 can be taken common. Plus F square minus Z square cos 2 alpha. Cos 2 alpha. This is equal to 1 by 2 F square into 1 plus cos 2 alpha plus Z square into 1 minus cos 2 alpha. You may write like this. Right? This is equal to 1 by 2 F square. It is nothing but 2 times of cos square alpha plus Z square. It is nothing but 2 times of sin square alpha. 2 will be cancelled. This is equal to F square cos square alpha plus Z square sin square alpha. Z square sin square alpha. Thus R square is equal to F square cos square alpha plus Z square sin square alpha. Therefore, R is equal to root of R. F square cos square alpha plus Z square sin square alpha. The resultant, the magnitude of the resultant of the two forces P and Q in terms of the greatest force and the least force have been calculated here. In terms of the greatest force and the least force. Therefore, question number 7 has also been solved. This one. Let's remove this one. Since we have solved this one. Now, question number 8. What is it? Now, I am going to solve the question number 8. Two forces P and Q acting at a point have a resultant R. The vector sign has been given here. You see. Have a resultant R. If the magnitude of Q be doubled, that of R is doubled. That of R is doubled. Again, if the direction of Q is reversed, then also magnitude of R is doubled. Three conditions are given here. Two forces P and Q acting at a point have a resultant R. First of all, you will have to write solution. Solution of question number 8. Let alpha be the angle between the two forces P and Q. Let alpha be the angle. Be the angle between the two forces. Forces P and Q. Let alpha be the angle between the two forces P and Q. Therefore, R square equal to. Therefore, in the first case, according to the first case, the case 1, in the question, resultant is R. R square equal to P square plus Q square plus twice PQ cos alpha. According to the case 1, you will get this one. R square is equal to P square plus Q square plus twice PQ cos alpha. Cos alpha is the angle. Now, if the magnitude of Q is doubled, the resultant R is also doubled. According to the case 2, if Q is doubled, then R is also doubled. Twice R square, P square plus twice Q square plus twice P into twice Q cos alpha. This means 4R square equal to P square plus 4Q square plus 4PQ cos alpha. Suppose this is number 2. This is number 2. Number 2. According to the case 3, now by case 3, what is case 3? Again, if the direction of Q is reversed, you see, this is P force, this is Q force. P force, Q force. Acting at a point O, suppose. The angle between them is alpha. If Q is reversed, suppose if Q is in these directions, what will be the angle between the two forces P and Q? The angle will be equal to this. 180 degree minus alpha. The angle will be equal to 180 degree minus alpha. According to the case 3, magnitude of R is doubled. Twice R whole square equal to P square plus Q square plus twice PQ cos 180 degree minus alpha. Then the angle will be equal to 180 degree minus alpha. Right? This means 4R square equal to P square plus Q square minus twice PQ cos alpha. Suppose this is number 3. This is number 3. Now, we have to find a relation between P, Q and R. No alpha is there. P, Q and R, no alpha is there. Therefore, eliminate alpha. Eliminate alpha from 1, 2, and 3. If you add 1 and 3, then alpha will be, cos alpha will be eliminated. Therefore, adding 1 and 3 we get. Adding 1 and 3 we get. 1 and 3 we get. 1 and 3. This twice PQ cos alpha, twice minus twice PQ cos alpha will be cancelled. R square plus 4R square. This is equal to 2 times of P square plus Q. Twice P square plus twice Q square. Twice P square plus twice P square. This means twice P square plus twice Q square minus 5R square equal to 0. Suppose this is number 4. This is number 4. Now, from 1 and now 2 implies 4R square. This is equal to P square plus 4Q square plus 2 times of twice PQ cos alpha. You may write like this. 4PQ cos alpha has been written as 2 times of this one. Or 4R square equal to P square plus 4Q square plus 2 times of. From 1, twice PQ cos alpha equal to R square minus P square minus Q square. R square minus P square minus Q square. You may write like this. Or 4R square equal to P square plus 4Q square plus twice R square minus twice P square minus twice Q square. This is equal to P square minus, this will be equal to minus P square plus twice Q square plus twice R square. Twice R square. And in the left hand side is 4R square. 4R square. Let me write. Yeah. This means P square minus twice Q square plus twice R square equal to 0. This is suppose number 5. Suppose this is number 5. P square minus twice Q square plus twice R square equal to 0. From 4 and 5 we get. From 4 and 5 we get P square divided by Q square divided by R square divided by P square divided by from 4 2 into 2 2 into 2 minus means I am twice P square plus twice Q square minus 5R square equal to 0 and P square minus twice Q square plus twice R square equal to 0. 2 into 2 minus 2 into minus 5 minus 2 into minus 5. Q square equal to 1 into minus 5 minus 2 into 2 2 into 2. R square equal to 2 into minus 2 minus 1 into 2. This means P square divided by 4 minus 10 equal to Q square divided by minus 5 minus 4 equal to R square divided by minus 4 minus 2. P square by minus 6. This is equal to Q square by minus 9. This is equal to R square by minus 6. Or P square by 2 divided by minus 3. Q square by 3 equal to R square by 2. P by root 2 equal to Q by root 3 equal to R by root 2. Therefore, P is to Q is to R. This is equal to root 2 is to root 3 is to root 2. From 1, 2 and 3, you can find 3 relations between p square, q square and r square also. From 2 and 3 also a relation between p square, q square and r square can be obtained. And that relations, and one of these 2 relations, 4 and 5, you can solve for p square, q square and r square, you can find this relation. The same relation will come. Dear students, perhaps you have enjoyed the class. We shall solve some more problems in the coming classes. Today I want to stop here. Thanks for attending the class. Thank you very much. Thank you.